Okay, welcome to the next installment of AC Theory. I want to go over a couple of things that we did on the quiz, a couple of problem areas that people had on the quiz. The first one was finding capacitive reactance. So there were two issues that some of you had. I'd say about 20% of you had one of these two issues with finding capacitive reactance. The capacitance that I gave you for the quiz was 0.044 microfarads. Actually, that's incorrect. What I gave you was 44 microfarads, which is 44 millionths of a farad. Remember that microfarads, 1 microfarad is 6 digits behind the decimal. So that's a millionth. If I was to say this is 1 millionth, if I was to say 1 over a million, remember a million is a 1 with 6 zeros, that is going to equal 0.000001. Those two things are the same, 1 millionth. So if I have 44 millionths, then it's going to be 44 divided by 1 million. And that's going to equal 0.000044. Because 44 millionths, if I'm thinking about this set of numbers, is 0.44. 0.44 microfarads is the same as 44 microfarads. So that was a problem. Some of you actually crossed out one of those numbers. I actually wrote it down to make sure there was no confusion and it didn't work. Some of you still got it wrong. If you wrote only 3 zeros and 44, this number is actually 440 microfarads if you take out that 1 0 and instead have the decimal place right here. 0.00044 is 440 because that's the same as this, and there are my 3 digits, 440 microfarads. So that was the first problem, is dumping the right number into the equation for 44 microfarads. And hopefully you guys are all clear on that now. If I've got a 3-digit number, it's real easy to say, yeah, those are my 3 digits for milli, because milli's 1,000th, and if I have 3 digits, I just dump 3 in front of them for micro, for a millionth. But there's a little more to it. You have to remember you have that 0 in there. It's a placeholder to make it the value correctly. The other issue people had is they forgot to invert. So when we're doing capacitive reactance, we've changed that formula. We learned that formula 2 pi fly, but when it's capacitive reactance, it's 1 over 2 pi FC. So in this case, in my calculator, I would say 2 times pi times frequency, in this case is 60 hertz, and then I would say times that number we just figured out, which was 0.00044. Now in the example, I actually gave you 44.21, I think. What I was trying to do is come up with a number that came out to 60 hertz. Most of you rounded that correctly to 60 hertz. So if it was 4421, then I would just, at the end of this decimal, hit 4421. Do the math on that. I would come up with some ugly number. I think it was, well, let's just do it in the calculator. I'll do it here with you. I don't even remember what the number is because it wasn't an important number to me. But I'm going to say 2 pi 60 times 0.0000421. Enter, and I come up with a number that's 0.0158. Let's see if I did this right. Some big ugly number, and I'm going to say, there, I'll write it down, 0.015871326. I don't care about that number, except that I'm going to invert that number. To invert that number, when it's on my calculator, I just hit x to the negative 1, and it pops up answer x to the negative 1. That answer, that equals 63. So I did do something wrong there, because I was looking for 60. Let's try that again. Clear. If I go, I wish I had the thing with me, 60 times 2 times pi times 0.0004421 equals, okay, I got a little bit different number this time. I think I fat fingered it the wrong time, which is easy to do. 0.0166666 forever, it looks like, or 6667. And then I'm going to invert that. Again, invert is this, the 1 over. When I hit that x to the negative 1, because this formula could also be written x sub c equals 2 pi fc to the negative 1. That's the same thing as 1 over. Remember, we learned that in our reciprocal formula for resistors. Answer to the negative 1, enter. And the answer I get here, and this is important, it's not that big a deal, and I didn't mark anybody wrong for it, but the answer I got from that was 59.9996. And then some zeros and a 156. If I round that number, 59.9996, if I round that number to 59.99, that's incorrect. Because the next number is a 9. If I'm going to round it to 2 digits past the decimal, the correct answer with this 9 here is actually 60.00. That's more accurate. 60 is closer to this number than 59.99 is because the next 2 digits are 96. In fact, even if I did 59.999, 60 is closer because 6 is more than 5. So when you're rounding, don't be afraid. If you're going to round, don't be afraid to round in the correct direction, even if it seems like you've rounded too much to do so, because this is actually less rounding than this. And this is an incorrect round because it went the wrong direction for the number of digits. Now, if I did 59.99960, that would be correct. And that now is closer to this correct number than this is. But we don't need to go there. Again, not a huge deal, but something you should understand about rounding is rounding is not just lopping off the digits you don't want. It's deciding on the last digit I keep whether I'm going up or down with that digit. And then it'll be closer to the correct answer. So those are the things I wanted to go over from last week. I am going to do another video in a minute we're going to take another look at capacitors in circuits. We're going to do it in parallel this time, I think, and we're also going to add capacitors and inductors. There will be no midterm. There will still be a quiz. I've decided not to do a bigger midterm this term, but to continue to give you a quiz on the material handled every week. So check in the Moodle. There is an assignment in the book for you to read and look at. I actually uploaded a terrific video from the 1960s, a guy teaching at an Air Force base, and it's really a terrific video. It covers all the stuff we have, and it kind of shows you where we come with technology as far as calculators and such as that, but essentially we're doing exactly the same thing because the physics of the electronics, the electricity that we're dealing with has not changed. So stand by for the next video.